I, I, I'm not sure this is working. Hello, here. Hello, hello. Okay, it's a pleasure to introduce the speaker today, which is Celia Anteniodo. She's from Argentina, but she works at Brazil. She's in the Pontifical University of Brazil, also in this Universidad Federal do Rio Grande do Sul. Okay, and she's been a visitor of FIFIS for many times. I think this is the fourth or fifth seminar she was here. She's interested in many things. You can see her webpage to see. She's interested in what we are interested, okay? In complex systems, nonlinear dynamics, and also stochastic processes, all sort of stuff. And the proof that she's interested in many things that I think she's never given a seminar on the same topic here. Okay, so this is again a different topic of the one that she's been given during the last 5 years. And this is an inequality in an agent-based model of capitalism. So we are eager to hear what you have to say.
Okay, thank you. Thank you very much for the opportunity. So I'm going to talk, as the title clearly says, about an Asian-based model. This is a very recent work done with Jordan. Is a PhD student that I am advising together with Sebastián, which is a professor at the University of Porto Alegre. So before describing you the problem and the results, I will talk a bit about a more general background. First, illustrate the kind of inequality we are talking about. Is about income and wealth inequality. Perhaps a rule that summarizes this kind of equality is that by Pareto, the rule known as 80-20, that he observed about the property of the land in Italy, where 80% of the land was owned by 20% of the population. So this rule, of course, is not exact. This proportion F1 minus F may change a long time and from one place to another, but it describes a general picture of inequality that is also represented here with more recent data of these are global wealth distribution. The colors indicate different layers of wealth. And on one side, we have the percentage of people, adult people, and in the other, the corresponding wealth, where here, if one makes the count, is still a bit better, a bit worse than the 80-20. I think that is 86-14 approximately. So this reflects the general form, shape of the distribution of wealth and also of incomes, where there is many people very poor and a few that are very rich. And this law can be related with the power law behavior of these distributions. There is a connection, if we assume a power law, between the F1 minus F law and the exponent of the power law. So there are many more pictures to illustrate inequality. I think this is enough. The questions that emerged, say, about the 20s is about trying to identify this inequality emerges from the interactions between individuals. So there is a class of models that I'm calling here random asset exchange models where interactions between people are pairwise, they interact by pairs and exchange certain amount of money, of wealth. So the thing is, with such kind of model, inequality can emerge and under which conditions. So I will illustrate this class that we worked with one exponent that is the so-called yard sale model. It's interesting because this is unbiased trading, and it is related to real exchanges. Perhaps in Europe it's not very common, but in United States, in Canada, I participated of this kind of trades, and also in Australia, it's very common that all objects obsolete or objects that people don't like anymore are exchanged sometimes by a value that is not the real one, is symbolic. So they offer in the yard or in the garage these objects, and there is an exchange. So there is a negotiation, and some wins, other losses. And so there are, as a result, small amounts of money that are exchanged. So this is the motivation of the name of this kind of model I will describe soon, that has been studied up to recently. So some concepts that will appear here. One is wealth. Here, wealth is used in a relaxed way as money or objects, properties that can be transformed in money independently of the liquidity. And also, since we are talking about inequality, there are measures of the inequality. A standard measure is the Gini index that most of you know, where one considers the cumulative wealth distribution. And in this picture, where there is a fraction of the population from the poor to the richer, and the cumulative fraction of wealth, there are two limits: one of total equality, where if all have the same quantity, so when we accumulate, there will be a proportion between population and wealth. And in the other extreme, all the population except one have zero, and one has all. This will be the extreme of total inequality. In the middle, there will be an increasing function that may have different forms. There may be some different concavity here. It's increasing. That is the Lorentz curve that reflects the particular cumulative wealth distribution. Okay, so this is already a picture of inequality given by this curve, the form of this curve, if it is closer or to one extreme of the other. But one measure is the Gini index, where is measured this, the proportion of this area. This is the Gini index. And it also can be calculated in terms of the PDF of the distribution of wealth, and this is the cumulative wealth distribution. So if we have a distribution, we can calculate easily the Gini index that can be applied not only to this kind of context, but also to any problem where we have a distribution of probabilities. Well, just to describe the yard sale model, I will talk a bit, mainly to contrast what with the model I will describe later. As I said, there are pairwise interactions. There is an exchange. Here I am writing mathematically the kind of exchange. The money that is exchanged in this case is the minimum between the wealth of the two interacting agents. Is the rule known as rule of the poorest. So this eta is minus or plus 1, indicating which is the agent that will win, which will lose. And this parameter epsilon is smaller than 1. This means that none of the two interacting agents will lose more than they have. And even this parameter is typically much less than 1. So very small quantities are exchanged at each time step. So this is the rule that is applied. It is a symmetrical rule. It is unbiased. There are other variants where we can favor either the richer or the poor. In this case, the quantity exchanged is symmetrical. There are other similar rules. For instance, this I have written here, where is actually another form of writing the rule of the poorest. So, see. Well, not necessarily. In the cases I will show, yes, it is conserved. Okay. In the exchange. You mean in the exchange? Yes. with this, only this rule, yes, because I can add other ingredients. Yes, but I can set it for all. In all I will show here, it is conserved, even if I will start adding other features, okay? Yes, but it's a starting point. I recognize at the end, I will say that this is a limitation, but we must start by some point, and the point is the conservation law, okay? Okay, so if one leave only this law, this unbiased law, initially there is no distinction between the individuals. They may start with the same amount of wealth initially. And what happens, many of you already know this kind of model, what happens, this is the initial condition where the Asians are all with the same amount, and after some exchanges, wealth starts to accumulate in a few, ends by accumulating in a single individual when the population is finite and there is a unit of money. But if you are in the continuum with infinite population and the amounts can be infinitesimally small, then what will happen is that the system will not arrive to a steady state. But in any case, there will be two phenomena here. That is, on one side, the concentration, as can be seen here, of the concentration in a few or single individual on one side, and in the other, what we call condensation in the lower part of the distribution, where except these few that have all the money, there will be condensation at or near zero wealth, okay? So if we measure the Gini index, this will increase always. And what results a long time is in the continuum limit is, here I am not showing this, but is similar, tail similar to that of Pareto law, but it will not evolve to the steady state. It will tend to concentrate in the larger wealth and condensate, on the contrary for you, in the lower ones. So this is what we observe in this Yersey model. So, see. Yes, this can be understood because even if there is conservation and the rule is symmetric, I think that if an individual gets very poor, and as the exchanges are a small fraction of the smaller of the two wealths, then for a poor guy to win, there may be many steps of success, and this will be highly unlikely. While the richer can exchange more money with rich people. So this is the mechanism. Thank you for asking. I was forgetting to comment on this. This is the functioning of this. For different initial conditions. The lower ones start from zero because it's a direct delta, the initial condition, or equal, and the other is some uniform within a given interval. So, well, let me comment. There are some mechanisms to avoid this condensation, which seems unrealistic. Well, to put some kind of bias that will favor the poor, also some kind of savings. If these savings are imposed, then the population will not condensate to zero. They will condensate to another value. No? It will depend on the distribution of the saving, or the detail of the saving, or some kind of regulation. So here our question was, how to introduce some kind of redistribution to avoid condensation and to reduce the inequality of the final distribution. So what we consider is some kind of mechanisms of collection, taxing, and then redistributing the collected amount using, for instance, a new uniform refunding among all the population will be like kind of subsidies. Okay. In this case, we are also imposing the conservation of the total wealth. So here we consider different laws, for instance, linear by parts that exempts those that have low wealth, or other forms that are power law that include the linear case, also progressive or regressive kind of taxes. And taking as a basis the yard sale model, the yard sale dynamics, we added this collecting and redistributive mechanism. So wealth conservation here imposes some problems, especially in the case of the nonlinear, because in the linear case, it is relatively easier, but in the nonlinear taxing, to fix the conservation, the total wealth, we need to vary with time some of these prefactors. So we consider cases that are fixing or varying the subsidies to adapt to the conservation of the wealth. So I will not talk about many details, just to show you that starting from a model, a simple model like the yard sale, we are including redistribution. And for instance, here in the case of nonlinear, we can follow the evolution. These are theoretical. I will show you, we can make a theory for the evolution of this problem. And the main results are that the extremes are suppressed. We don't have the condensation at low wealth, nor the concentration at high wealth. A steady state is attained even in the continued limit. And there are then some stylized facts of the distributions. There are, depending on the parameters, flat regions. There is a change of the skewness, bimodality, that will mean a stratification of the population or equally populated layers. And in any case, when I use this kind of nonlinear taxing, there is a reduction of the Gini index. But let me just tell a bit about the theory. One can obtain a kind of Fokker-Planck equation for this problem in this form, where we can found these Cramer-Moyal coefficients. The part of the exchanges will be related to a diffusive term, will give the diffusion of the fluxes of wealth, and the taxing and redistribution will be as a deterministic term that will stop this diffusive movement that leads to the extremes of concentration at dark wealth and condensation at low wealth. This is interesting because allows to understand better how is the diffusive movement of the evolution, and also under which laws we can act more effectively to contrarrest these fluxes. But when the problem is when we want to compare this with real world, beyond the question of wealth conservation, is very difficult, because here we have the background of the exchanges that may seem rather unrealistic. So to go further, we started to look for a model that were more realistic than these random exchanges. And this is the model I wanted to talk now. Also, beyond Pareto law, of course, there is not this kind of condensation in real distributions. But we have this kind of shape represented here through the cumulative distribution of income, in this case, and wealth, where before the Pareto regime, there is another regime, which is, in the case of the wealth, is exponential, usually called Boltzmann-Gibbs, but it's exponential. And in the case of income, it is not exactly exponential. In some cases, it may be close to exponential math, but may have other forms like log normal, for instance. Okay, so it has typically two regimes. So there has been a lot of effort to try to find with these simple models the reproduction of these regimes. So some artificial ingredients must be added in models like the year sale model to reproduce something similar to these two regimes. But looking for more realistic models, actually Jordan found, the student found this model that was proposed in 2005 by Jan Wright. Jan Wright is an economist, and this is the model we are considering here. What was impressive is, I will describe soon, this model has a few rules, 5 rules actually, and a few parameters, 3 or 4. We can scale and get 3 parameters. Actually, one I will show, that is one of our findings. And for instance, here I am showing some results of the model. This is a firm size distribution, which is, here is a log-log plot, is a power law. These are the results of the model, but Jan Wright compares the results with what is observed in real world. And it's impressive that the laws that come out from this model are the laws of the distribution found in real world, and even the parameters, the exponents, in this case, are also very close. He finds in the model exponent drawn in the picture, and this is an exponent reported for real data. Another is the firm's growth rate distribution. In this case, it is double exponential. And in the model, well, the figures I'm showing are all results of the model, but they are compared to real distributions. Here is the case of the Mises distribution that is approximately, he said, a log can be approached by a log normal, and he gets something perhaps not so log normal, but is very close in that case. Here is the GDP growth rate distribution that is also Laplace, double exponential. The duration of recession, and many results of the model. Is impressive that they are in agreement with distributions found for real systems. And in particular, the distributions of wealth and income, as you can see here, also reproduce those observed in real world. Here there is a decomposition. As we will see in this model, 2 classes arises, those of workers and those owners of the companies. And here there is a separation of the distribution for each one of the classes that allows to recognize each regime of the full distribution with the social class it comes from, both from wealth and from for incomes. Okay. So I will now describe this model. See. Pareto, yes, the Pareto law, this power law form is associated to the capitalist class. Okay, because it's the part associated to the, here M is wealth or money. he calls. And so this part is associated to those parts of the population that own the larger quantities of money. Okay? Yes. Yes, there is. And there is mobility also between them. Yes. Even so, well, this is the result of the simulation that we also verified and reproduced. We perhaps seeing the rules, it will be better understood what happens here. It was impressive, so we decided to investigate this model as a basis, then to perform similar analysis to those we have done in the yard sale, like the redistributive mechanisms, for instance. So here, the agents are all equal. There is not heterogeneity appear, but different classes will appear: the employer, the employee, and unemployed also. But essentially, we have the employees, the capitalists, and the employers, the capitalists, and the employees or workers. Okay? So each one of the individuals, the agents, moreover, agents doesn't need to be individuals. They may be groups, they may be communities, or even countries. And so the agents have initially a certain quantity of wealth. This is the quantity for each for each agent in the population. And there is also an index, this index, that represents it will be a number that will indicate which is the owner of the company the agent belongs to. If it's an unemployed or is a capitalist, then the index will be 0. Only workers will have an index that will be equal to the employer. So there is also another entity here that is the marketplace that will appear later. So the exchanges may be money exchanges, like those I have shown in the yard sale model. And the exchanges will be through payment of salaries, for instance, and also changes of wealth. People will buy goods or services, and enterprise will receive some returns by these sales. This will be equal to J, means that J is the capitalist owner of the company, see, the employer. So besides the changes of wealth, maybe changes of category, and this will be done by hiring or firing. So something that somebody who is unemployed can become a worker, or a worker can become unemployed. At the same time, if a capitalist fires all the workers, then they will become unemployed too. Okay? So also the capitalists can start as capitalists or can close also the companies and become unemployed. So these are the kind of exchanges. Besides money, there can be changes of category. Okay, this will be clear with the rules, but basically when people buy goods or services, will not buy this directly to a company. Will buy to this common place, and then the companies will compete to pick the money put on the marketplace to buy something, good or service, okay? With the rule, I think this will become clear. So I will describe now the rules. At the initial time, the model assumes that all are, try to recall these symbols. Initially, they are all the agents unemployed, and the quantity of money is the same for all. So the first step actually is not a step. I just select one agent. This will be repeated in time. Each Monte Carlo step will correspond to 1 month. And there may be some commutation of the order of the rules, but I will present it in this particular order. One action is hiring. So I have selected the agent E. If E is unemployed, then we can choose potential employer, potential capitalist, and the way we will choose the capitalist, the only thing that cannot be is, what is this? Sorry. This is the worker, cannot be unemployed. And so we will select the potential employee with this probability. So who has more money will have more chance to be the employer. Also, it's a step wage payment. Again, if in this case I is a capitalist, then we will pick all the set of all the workers of this capitalist and pay the wages. So there will be these money exchanges where this quantity P in principle will not be fixed, but will be selected randomly within a certain distribution of wages. Okay? So there are here 2 more parameters. And there can be firing. The firing will be defined by the possibility of the capitalist to pay the wages. If cannot pay all the wages, then we will establish a set that will be chosen randomly that will be fired, so that the capitalist can pay all the wages, remaining wages. And here is these are the 2 rules where enters the marketplace. So the marketplace is associated to what is called the market value, this variable B. When somebody buys something, then this agent will lose certain quantity that will be added to the market value. And then the revenues of the companies will be, this is not unemployed. Here, any one of the agents can buy something, but the revenues will be only for workers or capitalists, not unemployed. So this quantity will be subtracted of the market value and will go to whom? To either the company, if the agent I is a capitalist, or to the company to which the worker belongs, in case I is a worker. This is the mechanism of buying things. This see, if somebody is, if the selected agent is unemployed, then can be hired. Can be hired by, this is the non, but can be hired, well, I will not look the symbol, but can be hired by somebody that already has an enterprise or that is unemployed. Cannot be hired by somebody that is a worker. Another worker cannot open a company. Unemployed or capitalist, any of 2. Here is not allowed that a worker will open a company before becoming unemployed. Yes, exactly. This will open a new company.
How do people become workers?
Employers, well, this is the mechanism. If they are not, they are unemployed, then they can enter in this in this pool where we will choose who will hire this selected individual. So if this unemployed has a certain quantity of wealth, then can compete with non-null probability. Hiring somebody will become an employer. Yes. No, the worker cannot become employer in this model. No? Yeah, here will have to be unemployed first. Unemployed can go to capitalist. Yes. Worker. No. No, worker stays like before being hired cannot go. What? Yeah, well, yes, perhaps it's a limitation of the money. Well, but in some way, if somebody, well,
but it is not going to get fired. There is no mechanism to go outside the company. The only mechanism is that you get fired because the company cannot pay you the
yes.
That's the only mechanism to go out of to become an employee. No?
Well, here is this firing mechanism. If the company cannot pay,
yeah. A company that cannot pay you,
yes.
Then get an employer, they have a chance to
yes. Yes, the person, well, maybe it's a limitation of the model. There is also not the possibility of somebody trying to go to a company that will pay more, for instance. No?
They always stay as employers.
Until they are fired, yes. If somebody is a worker, somebody is a worker. Sorry, what? See, an employer. Yes, yes. If cannot pay, have to fire all the workers, will become unemployed. Yes, yes. Yes. Yes, and this is for all chain. I haven't written, but it's for all the workers of the. Not at this stage, only loses the wage that is paid. No, not directly, but can win through this competition at the marketplace. Okay, this is the rule where there will be a revenue of the capitalist. Okay. This expenditure, yes. Even unemployed will buy something, and
then it is distributed among the capitalists.
Yes, the capitalist. The capitalist, or directly. Yes, but but not to workers. Here, the money will be to the capitalist if the selected agent is a capitalist, or if not, if it is a worker, then the money will be to the capitalist that employs this worker. Okay.
Money among workers, among workers and companies, but the ones on the workers.
Yes, yes, exactly. At this station, the worker only receives the wage. Yes. Well, so just to emphasize here which are the parameters, there is the size of the system, there is the total wealth, and we have, in principle, this is a uniform distribution that he assumes. So we have the extremes of the wage interval, 4 parameters. But actually, there will be 3 because we can scale all by one of these parameters and set it as the monetary unit. There are 3 parameters. Okay. Any other question? This is the wealth. Well, here initially we have the total wealth, the number of agents, and all start with the same amount. There may be other initial conditions, but except if this exotic initial condition will end in the same steady state. Sí. Yes. I have simplified here, but there is, let me think, nobody can become negative. No, this is, yes, but it doesn't include a parameter, new parameter. Okay? These are the only 4 parameters. Sí. Okay, yes. Now I recall, now that you asked more emphatically, I made it's a quantity that is between 0 and the total weight of the agent. That is rather too much because somebody may go to 0 eventually, no? Okay? But then it doesn't include a new parameter. Sí. This in principle is not a fixed number, but it's a random number that you select from uniformly from this interval. Okay, so these are the extremes of the interval. Okay. Well, so I have shown some results, but here we were interested more in inequality. No? Here is a picture of the distribution of wealth and how they are distributed among the classes that emerge from the dynamics, are not imposed. And well, here are what we are looking for on first, the size of the system, the influence of the system size. So here is the wealth per capita within each class. The wealth per capita here, let me show you. These are results of 100 realizations along 1,000 years, and we fixed a certain wage interval with mean 50. And here we fix the wealth per capita, the average wealth. And what we see that increasing the system size, there is a large deviation around the mean, but in terms of the average value, you see that the influence of the system size, even for small sizes, we see that after a size small, that is 100, there is practically no influence of the system size. So this will indicate that above 100 individuals, we can neglect the size of the system, and in general, we worked with 1,000 or 10,000 individuals. Now, if we look at the wealth per capita, in this case, we are fixing the number of individuals. Always we are changing 1 parameter each time. Here we are changing only the size of the system, and here we are changing only the average wealth, the wealth per capita. And we are analyzing the distribution within each class in this plot. So here we see that in contrast to the system size, the average wealth has a strong influence. There is a certain regime where the influence is small, but then there is a kind of transition where if we put more wealth in the system, this will go mostly to capitalists. This graph already indicates, okay? Now, the effects of system size, also from another point of view, here are the wealth, the cumulative, the complementary cumulative distributions of wealth for different system sizes. I changed the parameter indicated in the title. And we see that in terms of Lorentz curves and also Gini index here, also we calculated another index of inequality, that is the Kolkata index, even less insensitive. We see that also in terms of the inequality measured by the Gini index, there is a small influence of the system size, okay? And this is for wealth and also for the incomes. Well, now in terms of wealth, we have seen in the previous picture, in the first picture I have shown, we expect a large effect. And in fact, we see that increasing the wealth per capita now in the whole population. In the first plot, this plot I have shown to you, there is a separation by classes. But now considering the whole distribution, we see that there is a flattening in this region which we are associated to a separation, a gap between the distributions, the two maxima in the PDF of the wealth. So there will be a concentration of wealth in the capitalist class, and this is also reflected in the Gini index, that for within a certain interval of wealth per capita, there is little sensibility, but then inequality increases, which is a reflect of the fact that there is a condensation in the of the capitalist class. And this is also observed, the distributions are a bit different for wealth and income, but the same effect is observed, okay? So this will mean that putting more wealth in the system will lead to more inequality. Here we also look at the effect of the wage interval. So these are different wage intervals with the same average. Here is all fixed. We also consider the bimodal case, 10-90, instead of uniform interval. And we see that here we are considering two values of the average wealth. In the average wealth is an important parameter. We consider a low value, 100, and a higher one, 600, to see what happens in the two regions. Here, you see that 100 is here, 600 is here, so we wanted to see in each region which is the effect of the wage interval. And each one is represented by these two colors. And you see here, all the cases are included, but all collapse. This means that the interval, or even we also tested shapes that are not symmetrical, that are not uniform. And so the wage interval doesn't matter, only the average wealth. The average wage matters. This is the conclusion. Well, this is very important because this reduces still more the number of parameters. The size of the system, about certain value, doesn't matter. There is a small dependence, but it's not a very significant parameter to worry about. But the wealth per capita is very important. So this is a parameter that then we can scale by the average wage. So actually, we remain with a single parameter. It's impressive that this robust, strong model that reproduces so real things has only actually a single parameter. So this quotient has certain restrictions, actually, must be larger or at least equal to 1 to start hiring, because of the condition to start hiring, the agent must have enough wealth to pay somebody. So if this condition is not fulfilled, the dynamics will stack. And also another case where we'll stack if R is too large, because if the wealth compared to the average wage is too large, the capitalist class will condensate to a single individual that will be so robust that nobody will be hired, and so nothing else will happen. This will happen in this economy. But in the more realistic intermediate interval of R, this is the relevant parameter. Well, so if then the curiosity arises, what happens in real world? So Jordan looked for data of the to compare the Gini index with the value of R. The value of R was estimating looking at the GDP over the average salary. For instance, this information is available for single country. It's better to compare because the criteria in different countries may be different. Here is for the United States in along this period of time, and you see that there is a small but a tendency to increase. When R increases, inequality measured by the Gini index increases. And here's another example that is with the G10 in a particular year, the same time of estimate of R, and you see that there is also a tendency to inequality increase with R, with a quotient between the wealth a country has and the average salary or wage, okay? Well, I think this was very interesting result. We have discussed it and showed this to Ian Wright, that is an economist, and he was very happy about these results. Also, we look at another aspect, the last, that is the persistence in this class, because we observed something that seemed unrealistic. As in many of these models, Asian-based, there are even in the water and in the noisy systems where there is a rapid exchanges of opinions or states that seems rather unrealistic. And here, what we see is that in terms of wealth, fixing obviously the average wage, what we see is that the duration in each class is very low, but increases when the wealth increases, which is associated to the fact that the wealth concentrates in a few capitalists that became very strong, very powerful, and then diminishes, and the break of the enterprise will become less frequent. And comparing with real data also, it seems, well, the scale of time of the model may be wrong, but for instance, comparing with this United States data, 50% of establishment fail in the first 5 years, which is of the order what we are also seeing in the model with the chosen time scale, where we attribute 1 month to each Monte Carlo step. Sì. This, sì. In the plot, from the results. Well, here is the duration is in months. You see, from 10 to 100 months. So it's within the order of 1 or few years, okay? But of course, the scale of the model could be also adjusted. It was when I think, see?
So according to this model, the employed people stay very long time. They're higher in wherever they want.
The unemployed stay, these are the unemployed, no? They stay. Sorry, I don't understand which is the question. Hmm. Huh. Sí, yes. Hmm. Ah. Ah, yes.
Technically, there is zero employment.
Mm, yes, they are. Yes, they are short time unemployed. Yes, yes. Comparatively with the employed during time. Hmm. Well, yes, we can compare. We have not compared in this case with the employed and unemployed times typically. Okay, it's a good suggestion to do. Well, so summarizing, well, we have revisiting this model that seemed to be promising first, looking at the results, but we inspected more closely some features, particularly related to inequality. No? And what is interesting also that the two classes, not only the wealth distribution, emerge spontaneously from the model rules. Actually, there are a few rules, no? And the model is robust. No? The weak dependence on the size depends only on the average wealth, that then we can fix the value in the same for all. No? It's not more a random parameter. And this is the relevant one. We verified with an estimate of R in real world that this tendency really occurs. And well, limitations, there are many that have been put here in the discussion. One of them is always present, is the uncriticized, is the question of the conservation of the conservative system, both on wealth and on size also. And there are many details of the model to scrutinize yet, but it seems robust. What we have tried to change, the main results are still very robust. So this is still in the archive, but I think that it's going to be accepted soon, because I said the first turn of reviewers. Okay. So this is all I wanted to show.
Okay, any questions? Have been already. Tony?
So this distinction that you made in the model, no, employer-employee, is this distinction clear in the wealth distribution of the data, of the real distribution?
Ah.
Because
you mean, for instance, it's not here. Here, this separate once we separate women, the distribution of wealth or of income in each class.
Yeah, this distinction between the wealth distribution of the employee and employer, is this clear in the data or?
No, I have not. No. Well, I don't know if there is data. I think that maybe there is, but but it seems reasonable, né? This kind of separation. You ask with relative to the precise law. Né? For instance, the regimes that we observe in the full distribution are actually associated to two kinds of agents, and this seems realistic. No? Yes, they know of the global, but we don't have a separation. The real data of the full, okay, but let me. This is the model. Here is the real data, but I don't know if there is a separation. If Whereas there is a separation, making some kind of analysis by layers of, but I don't know if by class. I have not seen by class, by social class.
Okay. No, that's, because maybe if I see the distribution of employees, maybe it will also be very wide, no? Because employee could be Cristiano Ronaldo, for example, is an employee.
Do you know, it's beyond that, but do you know of any model, ABM model, that by economic interaction, the global wealth grows? I mean, that's what politicians and economists say all the time.
Really.
But overall growth,
By inflation.
there is no model that you know of.
I just know models where inflation, certain effects are taken into account. But this will not produce, if there is a rule, then it can, variables can be scaled in some way. This is because this is tractable, perhaps these are the cases I know that can be treated in the literature.
Scale GDP by the number of GDP number of people adjust by inflation is going to increase of the total amount of
I don't know. That's what we are told all the day. Economic growth, economic growth, economic growth.
The banks are the point is that again, the unit of money is not well defined. So how do you measure that?
No, inflation.
No. Inflation is measured on a unit. The unit is not well defined. What is €1? No. 1 kilo of apples has one inflation, 1 kilo of oranges has another inflation, 1 kilo of bananas has another inflation. €1 is equivalent to 1 kilo of that today, not tomorrow. The unit of the money is not well defined. Is not well defined. There is no unit for the amount of wealth which is well defined, in the sense that is invariable to whatever, considerations.
My wealth is my money is
Okay. Define kinds of things and more. You can buy now more mobile phones and less houses.
Well, to add on this, I think it's because we don't account here, so there is no increase in global wealth because we don't account that the worker generates wealth, in fact. That's the whole point of the capitalist society, So it takes raw materials and it generates wealth in a sense that it creates a good for the market. That's the whole point of the... So that it's not stable, it increases, in fact. That's my opinion, at least, of the thing. I don't know.
Okay. Or see,
Thank you for the talk. Maybe I missed the point, but you said that the results are independent of the initial distribution of the wealth, no? Because you have a unique steady state.
yes, we have obviously done a very systematic study, but we have put fluctuations, we have varied a bit the distribution, but we have not also seen some extreme cases.
Yeah, but for me, this is not realistic, no? It's just a question of, I am not an expert in this. I would expect that if you have like a non-uniform distribution of the initial wealth, the ones that have more advantage at the beginning.
Yes, well, another thing that is related is the order of the rules. there is a specific order of the rules so that the dynamics will not get stuck. And depending on the initial distribution, there may be some problem with this. So we have, this is something we need to check what will change if we change the order of the rules. At the end will not matter, but at the initial stages, it may be important and will be related to the initial distribution.
Okay, thank you.
So Celia will be here still until Friday. She's in room 217. If you have any further questions, just go to her. Okay. Thank you.
Thank you.
Y lo mismo que la riqueza no se conserve. Estamos viendo el efecto que tendría si uno aumenta la riqueza por cápita, por ejemplo. Pero de alguna forma es un...
Yo te pregunto, el discurso capitalista es
Del tema de la calefacción para los precios, que se está firmado convenio, pero bueno, vamos a ponerlo en serio.